Okay, so this is our day 7 activity, last example. All right, so these two pulleys are connected by this belt or rope or whatever. Okay, so what does that tell us about the linear speed of those two pulleys if they're on the same belt?
They have the same linear speed.
Same linear speed, right? Because if I have a point here, it's going to go around here and around here. They're connected. So the two pulleys have the same linear speed, okay? But they have different radiuses, and the larger pulley rotates differently, right? Which one rotates faster? The larger pulley or the smaller pulley?
Smaller.
The smaller, right? Because they have the same linear speed, so this one's going to have to do more times, right, to keep up with that bigger one. So which pulley has the faster angular speed? The smaller pulley. Okay, so the angular speeds will not be the same, right? All right, so do we have enough information to find the linear speed of the belt? So if I have this point that's moving around, what's its speed? Okay, so our favorite formula for linear speed, the most useful one we have, is V equals R times omega. Get that one down. Okay, in words, that is, V is linear speed or linear velocity, equals, what does R stand for?
Radius.
Radius. What does what does omega stand for?
Angular speed.
Angular speed. Okay, so do we have that? Do we have the radius?
Yep.
Okay, and it doesn't matter which pulley I use? No, but I have to know the radius of that pulley and the angular speed of that pulley. Okay, so I could choose either one. I got the radius, but I need the angular speed. The only thing I even remotely know anything about is rotation. The rotations that it makes in a certain amount of time, revolutions, rotations, that's what you need for angular speed. It doesn't have anything to do with the radius. It's just how is it revolving? And then we convert that to radians per unit of time. So anytime you've got revolutions or rotations, easy to get that angular speed. So we are going to talk about the larger pulley. Okay? So I've got the radius of the larger pulley, which is
15 centimeters.
15 centimeters. I was going to write larger somewhere, but I don't know where I'm going to write that. Okay, so I got 15 centimeters. That means I need the angular speed of the larger pulley. So let's go out here and find it. Angular speed of larger. Okay, so the angular speed is what do we know about it? 25 revolutions or rotations in 36 minutes. Okay? Okay?
Seconds.
Oh, seconds. Yeah. It'd be like, it'd be so slow. Seconds. Okay. All right. So angular speed has to be in radians per unit of time. I got time. How do I convert revolutions to radians? 1 revolution is how many radians? 2 pi. All you have to do is multiply by 2 pi if you know revolutions. It really is that basic. Okay? So that becomes 50 pi radians. If we're writing it as an angular speed, we need radians. But if I'm doing it in a calculation for linear speed, I don't include it. It just looks like a unit I need to get rid of, and I don't. Over 36 seconds. Okay? Now, do I need to make that into per second? No, it's fine. It'll come out in the wash just fine. Okay? So we've got 50 pi radians per 36 seconds. I mean, I don't think I converted it. Okay? Now, do you want to reduce it? Maybe we want to reduce it first. That'd probably be a good idea, huh? 50 over 36 reduces to
25 over 18.
25 over 18. So I would do that first, but don't turn it into a decimal, use exact. We don't want to round to a decimal till the very end if we don't have to. So it's 25/18 pi radians per second. So I'm going to reduce that here. Okay, so 25/18 pi seconds. Okay, so this is giving me the linear speed of the belt. That's it. All I have to do is multiply across the top, multiply across the bottom, divide, I got it. So here's where I would say, I mean, if you want to do that, we can, but I like to check, do I have the right units? I have centimeters and I have seconds. So this would be in centimeters per second. Is that what we want?
Yep.
Oh. That wasn't that bad, was it? It's really not that much, you know, to bring together. But understanding these things takes a little bit. I get that. Okay. So what do we do? Multiply, I guess. I don't know why I'm looking here. 15 times 25/18. I don't know. I just make my calculator reduce. So I get 125/6 pi. And that is centimeters per second. So this is an exact value. Okay, that's exact. Now, if you're talking about a speed of 125 pi over 6, I mean that, or what? So I would turn it into a decimal to make some sense of it. So you can punch that in your calculator. So I did the multiplying and I made my calculator reduce the fraction. I do not do that on my own, and I don't expect you to either. Okay, so I think, see, let me know, Dan, I think you had this. Did I get this right?
Oh, I left the first.
You left it the exact?
Yeah.
Okay, so I don't know if anybody has punched it in, but approximately 65.4 centimeters per second. Anybody else get that besides me?
Yes.
Okay, so it's traveling at that speed. Okay, so that would be the approximate. Okay? Questions? Austin?
Did you put in the pi, 2 pi into that, or am I missing something?
Over here?
Yeah.
For the angular speed, I did
Oh,
25
okay.
times 2
Never mind.
pi
I
is
see that
50
now.
pi.
My bad.
But then I reduced it.
I got you, okay.
Okay.
Thank you.
You don't have to reduce it. I mean, really. I mean, if you're giving something exact, we typically do, but it could have been reduced through the process also. Okay? Everybody good with that? Okay, so what does part C say? Find the angular speed of the smaller pulley in radians per second. Okay, so angular speed, then we need to know here's a couple things we can think about. We need to know what angle does it make in a certain amount of time. That's what angular speed is. Okay, an angle in radians. But that would require me to know something about revolutions. I don't know anything about the revolutions. Okay? So another thing to think about is this formula can be used to find any of these 3 variables if you know the other 2, right? We're good at formulas. You know 2 of the values, use it to find the 3rd. Okay? So let's think about that. Do we know the linear speed of the smaller pulley?
Yes.
Yes, because this is the linear speed of both pulleys, right? Both pulleys have this linear speed because they're the same. Okay? So maybe make a note of that. Both pulleys. Okay, because they're connected by the same belt. So I know the linear speed of the larger one, I know the linear speed of the smaller one. Okay? So we're talking about the smaller pulley. Okay, I know its linear speed. Do I know its radius?
Yes.
Okay, what am I trying to find? The angular speed. So I can use that formula to find angular speed. It's a multi-purpose formula. We like it. Okay? So I'm going to start with that. Here we go. And I'm going to substitute. Linear speed is 65. Oh, should we use exact or rounded?
Exact.
Yes, thank you. I like that. Good answer. Good answer. We should use exact, which is 125 pi over 6, and that is centimeters per second. And the radius is 8 centimeters. And I'm trying to find omega. Okay? So we just have to solve for W, which looks like a W, right? Okay, so how are we going to get this thing all by itself?
Divide 8.
Divide. So we're taking 125 pi over 6 centimeters per second. Whoops. And we're dividing by 8. Now, how you do that, write that is up to you. But remember, when you're dividing with a fraction, you multiply by the reciprocal. So you could have multiplied by 1/8. So if I write that, it would look like this: 125 pi centimeters per second times 1/8 centimeters, and that's going to give me omega. So why am I doing these units? To make sure, oops, I think I need to, what's the problem here?
105 over 6.
Yeah, I have to put, oh, but look, my units should divide out though, but that doesn't look right. Do I have to flip that with it? I think I have to flip it with it.
Your centimeters is on the bottom.
Yeah,
So it's 1/8. It's
Yeah.
you're dividing by 8, so it becomes
Yes,
the centimeters
thank
on the
you.
bottom.
I
and
need
then
to
the
write it on
centimeters
the
cross
bottom
out.
so it looks like it cancels, yes? Yes, thank you. Is that better?
Yeah.
Centimeters are gone. That's the idea, is we gotta get rid of the, make sure that those are the same units. So what do we get? We get
25 over 48.
125 pi over 48 radians per second. Exact, turn it into a decimal. I have 8.18 if we go to 2 decimal places. I don't know why I chose 2 decimal places, I just did. Doesn't really say, does it? It says exact, but. Did anybody else get that?
I did it.
Yep.
Okay. All right. So, the last step's just go in the other direction. If you know angular speed, can you find revolutions?
Yes.
Right? So, maybe just do one of those. Should we do let's do the smaller pulley since we haven't. Okay? So the smaller pulley, we know that its angular speed is 125 pi over 48 radians per second. What do we
45.
need? What's wrong?
It's 45 now. 6 times 8.
I thought 6 times 8 is 48,
Oh.
I think.
It is.
Okay, so we need revolutions per second. So I need to go from radians to revolutions. Think dimensional analysis, right? I need revolutions on top. I need to get rid of radians. Here's where the radian thing might be helpful for canceling, but there's John. That's how I can decide which one goes where. So 1 revolution is 2 pi radians. So when you're going backwards, instead of multiplying by 2 pi, you are dividing by 2 pi. And if you're not good at making your calculator do this stuff for you, come talk to me. I mean, seriously. I just make my calculator do my fraction work. I mean, reducing and stuff like that. Or turn a decimal back to a fraction. Oh, we love that. So look what happens here. The pi's will cancel. So we have 125 over 96. Does that seem right?
Yeah.
96. That doesn't reduce, does it? I don't think so.
No, it does not.
Okay, so if we want a decimal, that would be
1.3.
Oh, I lost a one. Oh, I'm on the wrong one, sorry, I was on the bigger one. 1.3 revolutions per second?
Yes.
Okay, so the larger pulley then is going to have a smaller angular speed, which is 0.69 revolutions per second, is what I got.
694, close enough.
All right, cool. I'll take it. Okay, so do you feel like you could do the larger one? Just, we have the
Per
angular,
second.
don't we
Yeah,
have
per
some
second.
angular speed?
I guess, do you just do 25 divided by 36?
Yep.
Okay,
We kind
cool.
of give it a.
Wait, no.
Say that again?
Yeah, 25 divided by 36, because it's 36
25
seconds.
revolutions.
Yeah, you just divide
36
the
seconds.
revolutions by time. You get,
Yeah, that's right. You're given
But
in the
with
question.
36 still, but
Yeah, they give us the
still-
revolutions per second, you just convert it to radians. Or, sorry, they give us
No,
the,
yeah, shouldn't we just leave it as 25 or
36
36?
seconds.
oh, yeah, that's right, we do have it. Right, we have it revolutions per second, so
We have, or wait.
divide. We don't have to do any
Oh,
converting,
that's
do we?
the- wait.
that's the angular speed. Revolution.
Can you use the angular speed? Yes, but you can use the revolutions too. Actually, it gave us that, didn't it, in the
Yeah,
very
yeah.
beginning?
In 36 seconds.
Yeah,
But
but you-
then-
So the
it's
larger
just
pulley
dividing revolutions.
is making, what was it? 25 revolutions in 36 seconds. Okay, so we've got revolutions per unit of time. We usually just like it per 1 second. Okay, you could take that angular speed and then go back, same thing. It's just more work. So that becomes 0.69 revolutions per second. Okay, so revolutions, rotations goes with angular speed. You do not use radius. Radius you use for linear speed. Okay. Questions? I guess in this situation we did have to use the radius, but the idea of angular speed doesn't involve the radius. Okay. All right, so this is your day 7 homework. How many people have started it? Okay. Probably when you do more practice and a little repetition, I think that will help. Okay, if you have questions, come see me, email me, whatever. All right. Okay, so let's jump back in. Let's see. We are in the middle of day 9, Art, right? We've got the concepts, we just need to finish it up. So we're on day 9 activity. And so I'm gonna do a couple more and then you're gonna get a practice, okay? So let me think about the page that we're on. I'm not sure about the page. So everybody find day 9. Page 5? Thank you. Okay, so we didn't do anything on page 5? Okay, so we did 2 examples on page 4. You think we need another refresher one today?
Please.
Okay. I have lots of videos in D2L that, of graphing trig functions that you can watch also if you're interested. But I am recording these and I'm posting these videos. Okay, so day 5. Oh, here we go. All right. Or page 5, I mean, did I say day 5? Okay. All right, so here's my function, y equals 3 minus the cosine of 1/4 x plus pi over 2. Okay, do you have an idea what we need to do first? There's something you absolutely should do first. Cameron. Sorry, here we go. Okay, rewrite it, and how do we do that? Okay, make the 3 go at the end. That's one thing, yeah. You don't have to do that, but a lot of people like it. And I am one of those people also. So what am I left if this is a positive 3, so it's a plus 3 at the end. So yes, you can move it to the end. That negative stays on the cosine though. Okay? So plus 3, okay? That is optional. There is something we must do, though, before we ever start into the filling in the table. Anybody remember what it is? Look at the last example. factor out what?
1/4.
The 1/4, right? You have to rewrite this inside here. We have to get rid of the 1/4 on the x, okay? So inside there, you're gonna factor out 1/4 from these two terms. So you're dividing both of them by 1/4. So 1/4 x divided by 1/4 is x. Pi over 2 divided by 1/4, pi over 2 divided by 1/4, multiply by the reciprocal. What do we get? Pi over 2 times 4 over 1.
4 pi over 2.
So what does that give us? 2 pi. All right? Plus 2 pi. Okay. So just FYI, this graphing is on the next assessment next Wednesday. And this is the way I want you to do it. I want you to give me the first cycle transform showing the 5 points. Okay, so now I'm ready to get all the parts here, the players. Okay? So, first of all, what is my A value? It is -1, right? A is -1. A tells me if there's a reflection and tells me the amplitude. Is there a reflection about the x-axis, yes or no?
Yes.
Yes, because why?
A is negative.
A is negative. What's the amplitude?
1.
The absolute value of A is 1. Okay, that means 1 up, 1 down to get from the midline to the max and the min. The period, how do we find the period? What's the formula?
2 pi over b.
2 pi over B. So, in my equation, what is B?
1/4.
If you need to look, remember this page? This is your friend. Okay, this has got all the good stuff on it, if you're stuck. Okay, so basically what we're doing is whatever was x was multiplied by. So if you factored it out, that's your B. Okay, so our B is 1/4, right? So we've got 2 pi divided by 1/4 tells me that the period is then 8 pi. Okay, so from beginning to end, it's 8 pi units. All right, phase shift. What does that mean, phase shift? Say it in real people, normal language that we're used to. Left or right. Okay, are we shifting left or right?
Left.
We are shifting left. Remember, it's opposite of this. So this is a shift left. How many units? 2 pi. Okay, so that's the transformation we're making. What is the phase shift? It's a number where the cycle begins. What is it? -2 pi. If you're shifting to the left, your phase shift is negative. If you're shifting to the right, your phase shift is positive. Remember, you're taking that first cycle, the first cycle of, is this cosine? Here's the first cycle of cosine. Remember, it starts at 0. Okay? I am moving this point to the left 2 pi. So that means it starts here. This is the new beginning. Okay? So if you're moving it to the left, whatever, you went from 0, that distance to the left. Okay? All right, vertical shift. Are we doing one?
Yes.
Which direction and how far?
Up 3.
Up 3. Okay, so that's my new midline. From 3 up, I'm going to go up 1 and up and down 1 to get to the max and min. Okay, so what we need to do then is we need to label our x-axis so we can see the beginning and the end of the period, the cycle, first cycle, and we can divide it into 4 equal parts. Okay, so we're beginning at 2 pi, so I'm going to write this here just, this is where we begin, this is the phase shift. So where does the cycle end? I like to do this because it's a check for me to make sure I got everything jiving. Okay? So if we're beginning at -2 pi and the period is 8 pi, so I'm going from, I have to take -2 pi and I have to add the period, and that's how I get the end. So what is -2 pi plus 8 pi?
6 pi.
6 pi. Okay? All right, so I think I can go with 2 squares. So here's my beginning, negative 2 pi. I'm going to make 2 squares, make each, section. Okay, so 1, 2, 3, 4. So I should have 5 numbers, which means I divide it into 4 equal parts. So the end is going to be 6 pi. So then I need to label those in between values. Sometimes it's easy to do without any special calculation. Maybe you're comfortable with that. Could you label those tick marks appropriately? Raise your hand if you feel good about labeling those appropriately. Okay? I won't go through the tediousness unless it's nasty fractions then, if you're okay with it. So this is 0, because that's our y-axis. So this is going to be
Oh,
2 pi. This is going to be
4,
4 pi. Because you're adding 8 pi and dividing up into 4 parts. So each section is 2 pi. Okay? Good with that? Label the y-axis. Okay? We're going up 3. So our midline, this midline, the x-axis, goes up 3. So I'm going to mark that on my y-axis. So this is, you don't have to do this. I do this for me so I can keep track. This is our new midline. That's our x-axis, so to speak. Okay, so we're going to pretend like it's the x-axis, and we're going to go up and down from there. So the amplitude is 1. So the highest point is going to be at 4. The lowest point is going to be at 2. Okay, so that's all I need to label, then I know where to go. And then I can read the graph quickly, right, and see what the range is, etc. Oh my gosh, we got the hard part done. Okay, so now what are we going to do? We're going to locate, well, here's basic cosine, yes? Okay, but we got to keep in mind we are reflecting. So if this is our midline, right? So instead of starting at the max, we're going to start at the
minimum.
min. Now, if you feel better about drawing this one lightly or dashed, and then you want to reflect it, I'm okay with that. I just like to do it all in one swoop. Okay? So this is what we want, is the red one. Okay? All right. So go to the beginning of the cycle, and we are going to start at the min. So we're at 2. So here at my phase shift, that's the beginning, I'm at the minimum value, which is 2. Okay? Then I go to my next tick mark, the quarter, and remember you have to cross the midline before you can go up to the top. Okay? The middle is 2 pi, I'm up at the max. The 3/4 is 4 pi, I'm back at the midline, can't get to the bottom unless you cross that midline. And at the end, I'm at the bottom. So remember, cosine, beginning and end is either high or low. You're at the same place. And here's what we got. That's the first cycle. Now, that technically goes on forever and ever in both directions. So don't think that's our domain. The domain is all real numbers. If we wanted to draw more cycles, then we would just repeat that pattern to the right or to the left. But you only need one, because that way it's easy to see all the parts. Okay? And then the range would be from the lowest to the highest, which would be 2 to 4. Any real number between 2 and 4 and equal to those. Cameron?
So on the assessment, is there going to be cosecant graphs?
Yeah. Yeah, we're going to do those in just a second. Yeah. So yeah, that's good. You did that in your pre-work, right? You did secant and cosecant, the reciprocals. So those rely on the fact that you can graph sine or cosine. So that's where you're going to get your practice in a little bit. You're going to do the sine and cosine and then extend the secant and cosecant, put the asymptotes. Yeah, so it's graphing sine, cosine, secant, and cosecant on the assessment. There are the other two functions, tangent and cotangent. We'll do those in a little while. They are very different. These two are super similar, you can see. So we'll take a break from graphing for a little bit, and then we'll come back to the tangent and cotangent. We didn't want to throw them in before the assessment and scramble things. Okay? All right. So let's do, I mean, I don't want to take control, but if you want to see one more, this one has a little more fraction work, because then what's going to happen when you get to these, to graph this one, you're going to have to graph y equals negative sine 1/2 x plus pi plus 1. So you're going to get practice graphing on these secant and cosecant graphs. Okay, so I don't want to take all your fun away. Okay, so let's just do one more, because I feel like seeing the little bit nastier numbering on the axes might be helpful. Okay, all right. Do we need to rewrite this?
Yes.
Absolutely. Look inside the parentheses. X is multiplied by a number, and I'm adding or subtracting something. That means you have a period change and you have a phase shift. So you have to factor. If you don't, you'll still have the right period, but your phase shift will be wrong, and everything else will be fine. So you don't lose as many points if you do everything else right. But I don't want you to lose any points. Okay, so here we go. So rewrite it. If you want to move the 1 to the end, that's fine. So this is 3 sine. So what do we need to do? We need to factor out the 4 from those two terms inside the parentheses. Okay, so we get the proper values. Isaac, do you want one of these? I have extra. Were you here on Monday? You were.
I was.
You just forgot it. Okay, yeah. Yeah, if you forget your packet or something, a lot of times I have extra, so just give me a shout, okay? I might have one for you. Is there anybody else that needs one? All right. So what do I get when I factor out the 4? What do I get inside there? X minus what? Pi over 4. Okay, now I'm going to let you fill these in and see what you come up with, and then I'll write them up there. Okay, you make the decisions about these 5 things, and then we can talk about setting up the x-axis. That's usually the trickiest part. Let's see how you feel about that. Oh, yawn, that's bad. Like, do you ever wake up some days and go, you feel like the time to make the donuts guy? That was me today. I'm like, what day is it? Where am I? Do I really have to get up? It was so bad. And I immediately made coffee. So, no donuts, unfortunately.
Oh, wait, sorry, I've been doing fine.
How did I do?
And so
I need help. I need you to tell me how I did.
So
Yes,
this is,
we can't vote.
so it's just the,
Either we're all wrong or.
plus pi over 4, because if you're looking at the
so it starts at, it would start at pi over 2 and then move to the left.
Okay.
right, so it
Is everybody okay with that?
would, like,
Or do you want to talk? Isaac?
So should you, when you write phase shift, you just write it without the sign?
Well,
I mean
if
the
it's
actual-
positive, you can put the positive,
Okay.
but if it's negative, you have to put the negative.
Okay.
Yeah, it's not bad if you put the positive, it's totally fine. Okay?
right.
All right, so where are we starting?
Pi over 4.
Or beginning? We're starting at pi over 4. Do you like to do the ending? I like to see the ending. Okay, so where are we going to end?
Pi over 4,
So we're going to add,
2 pi 2.
we're going to add pi over 2. So you're going to have to do some fraction work here. Use your calculator. You know, you don't have to put the pi's in your calculator, just put 1s in front of them, right? If you need to do the fractions. Okay, so I need to get a common denominator here. That would be, oopsie, wrong one. Well, what's 1/4 plus 1/2? Can you do it better like that?
Yeah, but I just did the same thing.
This would be 2 pi over 4, okay? So we're going to end at 3 pi over 4,
Yes.
okay? Now, sometimes finding the in-between's a little bit harder because you're gonna have to find probably some halfways kind of thing. So I don't draw this yet because I gotta get a feeling for what my units are gonna be in kind of a scale. Okay, so if you need to then, to get those 5 values, because I'll write them here. So here's our phase shift. So then we start here. We have to have 4 more values, or basically 3 more. I know I have to end here. Does that make sense? So what are these tick marks in between? If you're comfortable doing it, dividing it up like that, that's fine. Whatever, however you do it. You can find the midpoint of these two and then the midpoint. Or you can do that quarter period thing that we did in class on Monday, which a lot of people use and like. Okay, so take 1/4 of the period. So what's 1/4 of pi over 2?
1/8.
Pi over 8, okay? So that's what you're doing. Each of those are spaced pi over 8 units apart. So you are going to add pi over 8, add pi over 8, right? You're just going to keep adding, okay? So I don't know about you, but I like to get common denominator and just keep adding in the same denominators and then reduce. So this would be how many? 2 pi over 8? So 2 pi over 8 plus 1 pi over 8 is
3 pi over 8.
3 pi over 8. Plus 1 pi over 8 is 4 pi over 8. Plus 1 pi over 8 is 5 pi over 8. Plus 1 pi over 8 is 6 pi over 8, which reduces to 3 pi over 4. There's your checking process. Okay. Then, of course, I would simplify this to pi over 2 when I write it on my graph. Okay. So, should we just make 2 squares? Is that going to work? 1, 2, 3, 4, 5. So this is pi over 4, and then this would be 3 pi over 8, and this would be pi over 2, and this would be 5 pi over 8, and this would be 3 pi over 4. So pi over 4 is yeah, that's good. I mean, we're not going to hassle with the square thing. Just can you divide it up equally? Okay. That's a big deal, but yeah. Okay. All right, let's label the y-axis. Up 1, that's my new midline. So, ooh, let's see. What's our amplitude? 3? Oh, I can't do 2 then. Dang it. Okay. So this is the new midline. This is the new x-axis. So the highest point is going to be how many up from there? 3, the amplitude. 1, 2, 3. So that's 4. 1 plus 3 is 4. And 1 minus 3 is going to be at?
-2.
-2. This is going to interfere with my big writing. And tell. All right. Then you're just going to find your points, determine if you have a reflection, and plot your points, your 5 points. Okay. So what are we doing? We're doing basic sine. Remember sine, beginning, middle, and end? We're on the midline. We go up to the top first, down to the bottom second, and there is no reflection, so that's our shape. How to practice those basic ones. Okay, so here's the beginning, pi over 4. Halfway, we're on the midline. And at the end, we're on the midline. I love that. Sine is, I think, easier in my head. Okay, because I know that's going to happen. Then I go up to the max at the quarter point. Oh, whoops. And I go down to the min at the 3/4 point. It's kind of sad. I can't make beautiful curves like you all do. Especially not on this thing. So domain, of course, is all real numbers, domain of sine and cosine, always. And then my range is from -2 to 4. Right, the amplitude is 3, so 3 times 2 is 6, so from high to low is 6. How do you feel about that? Are you feeling a little better? Maybe now that you do some practice, it'll sink in a little bit better? Okay. Questions before we go to break? Cameron?
So, I've already answered this, but is there gonna be like ever a origin function that works as?
No, the only, no, we only do reflections of graphs about the y-axis, right, when we take the opposite of the x, or about the x-axis when we take the opposite of the function values. So no, we do not do any of those with graphs. Yeah. Some things have origin symmetry, but we don't reflect about the origin. In here anyway. Okay, so take a break.